Good evening to all of you. Today we'll see the last topic of the fluid statics, that is the pressure measurement topic. So in the pressure measurement topic, we are going to say which are the instruments we are using to measure the pressure. Basically, the pressure measurement instrument, there are two types. We are taking it into the types. One is the mechanically we are measuring by means of some piezometer or barometer. For the barometer is used to measure the atmospheric pressure measurement purpose. Another thing is in the pressure measurement, there is a U-tube manometer we will use. So it will particularly, it's a different variation of the U-tube manometers. There are several types of the U-tube manometers. And another part is the pressure gauge we are using. Whether the pressure gauge is the Bourdon type pressure gauge we are taking here. Another the things, some pressure transmitter is we can use. That means the mechanical pressure is converted into some other signal through the transducer. And this signal is measuring the pressure in different manners. This kind of the pressure measurement is the piezoelectric type pressure measurement. So there are different ways to measure the pressure. In here, in the scope of the study, we will talk about the mechanical type of the pressure measurement. We'll see the manometer first in our topic. So we'll come back to the manometer. So the pressure measurement, the spelling is some mistake. So pressure measurement types is the manometer and mechanical gauge pressure. So in the mechanical gauge pressure, you will see here. So there is a pressure measurement. And the pressure measurement manometer, one type is the manometer, another type is the mechanical gauge is there. So under the manometer, through the manometer we can get the absolute pressure. So through the manometer we can get the absolute pressure. Or we can get the differential pressure also. In between 2 points, what is the differential pressure? So if we get the differential pressure, so this kind of so in the 2 point is given to you, the difference between the 2 point pressure you have to measure through the differential manometer. Whereas the simple manometer is used to get the absolute pressure or gauge pressure. Gauge pressure means how much pressure is above the atmospheric, or vacuum pressure, how much vacuum is maintained. These three measurements can possible through the simple manometer. Whereas the differential manometer, only differential pressure we have to measure this. Other than this, the Bourdon tube and pressure transmitter is also in this scope. So the Bourdon tube, pressure gauge we are using, and pressure transmitter. In the pressure transmitter, I have already told you the pressure is converted into the different signals. And from the signals, we are getting the pressure values we measure. So in such a cases, the piezoelectric material we are going to use piezoelectric pressure measuring device. So it is the piezoelectric pressure measuring device. So absolute pressure, gauge pressure, just one recap of this thing. So absolute pressure means from the zero, what you are getting is the reference line. You're creating the reference line where the absolute pressure is set. Absolute pressure here is 0. That we are taking as the reference line. Now for a point, what is the pressure? So how much it is up above the absolute reference line. So this will gives you the point 1 that you take is, so pressure is the P1. Whatever you're measuring, that is the absolute pressure. So at the point 1, whatever the pressure you are measuring, that is the absolute pressure. Another thing, the atmospheric. So in atmospheric air, some point is the atmospheric condition. Here it is. It will take some point. A, small a, is the atmospheric condition. So here it is not A, it is absolute AB. So this pressure, the absolute pressure of the atmospheric, so PA is, we are considering here 1 bar pressure or 1 atmospheric pressure, which is nothing but 1.013 into 10 to the power 5 Pascal. And write it down. Or we can be able to say 101.3 kilopascal. In this manner, we could be able to write it. That is the atmospheric pressure, absolute values. Now the condition is coming, that is the gauge pressure. So gauge pressure, in case of to find out the gauge pressure, the absolute pressure line is not more consideration. Here, the consideration will be the atmospheric pressure. So this atmospheric pressure, if you take it as a reference, this atmospheric pressure, if you take as a reference, so atmospheric pressure is taken as a reference. So at the point 1, what is the pressure of the here? With reference to the atmospheric pressure, here the pressure is P1 minus PA. So this pressure is known as the gauge pressure. As P1 is more than PA, because this point is higher, P1 is more than the PA. So this amount is called the gauge pressure. Here it is the gauge pressure. So how much it is more than the atmospheric pressure, this difference amount is known as the gauge pressure. So gauge pressure means any pressure of any particular point minus atmospheric pressure. It gives you the gauge pressure. On the other hand, the vacuum pressure. Vacuum pressure means it should be below the atmospheric line. Here, some point you take it as a 2. So 2, the absolute pressure of the point 2 is P2. The absolute pressure is the P2. But vacuum, if you are asked how much vacuum it is, vacuum pressure. So vacuum pressure will gives you P atmospheric minus P2. This will gives you the vacuum pressure. That much amount of vacuum is there. For the sake of the example, here, the atmospheric pressure, it is below. P2 is less than the atmospheric pressure. As P2 is less than the atmospheric pressure, so it is under vacuum. It can be better understood by some example. Let you take one physical example in the power plant. That is condenser. Condenser pressure in a power plant. It is maintained nearly 0.1 bar absolute. 0.1 bar absolute is the condenser pressure we have made. So if you want to convert this thing in terms of the vacuum, so 0.1 bar. So 1 bar pressure, 1 bar is the atmospheric pressure. 1 bar absolute is the atmospheric pressure. So 1 atmospheric, that is, which is nothing but, we know that is the 760 mm of Hg, mercury column, Hg column, 760 mm of Hg column. You will get it, this thing from Torricelli equation, but and just give you the scope. 1 atmospheric pressure is the 760 mm of Hg, or 1 bar absolute. That is the same thing. So 0.1 bar absolute is nothing but 760 divided by 10, so 76 mm of Hg. That is the absolute pressure. So if you convert this thing into the vacuum, how much vacuum we are maintaining? If you are asked is how much vacuum we are maintaining in the condenser, so vacuum pressure, you can write it down. 760 is the reference minus 76. So it will comes around 684 mm of Hg. So the vacuum is 684 mm of Hg for the condenser. Just is a conversion. We convert this condenser pressure, absolute pressure, in terms of the vacuum. That is the way. So that is the transformation in here. So I hope it is clear to you, because just absolute pressure, we are getting the absolute values, and vacuum means the 760 is the reference line. So 760, how much below we are going to get the condenser pressure? So here it is the condenser pressure. See, PC. So how much below it is? That is the 684 mm of Hg. About this reference. So from here to here is the 760 mm of Hg. Here to here is the 76 mm of Hg. So how much vacuum? 760 minus 76. So 684 mm of Hg. That's all here.